Welcome back to Maths Made Easy. Today we'll be looking at grade 11 trigonometry revision. So the very first question that we are going to be dealing with is Pythagoras problems. So now let us look at this question here. It says that if sine of beta is equivalent to 2 square root of 6 over 5 and beta is an element of 90 and 270, calculate without the use of a calculator and with the aid of the diagram the value of the following. So they will first want the value of the tangent of beta, and secondly they want sine of 90 degrees plus beta. So now how do you answer the question? I think the instructions are very clear. So what I normally refer to this problem as, I call it a two-hint problem. So meaning that this is hint number 1 for me, and secondly this is my hint number 2. So in order for me to be able to answer this question, I'm going to make use of hint number 1 and hint number 2. So how do I use these hints? This is how I go about it. I draw a cross like this. I check, what is this? This is sine. Where is sine positive? Because I don't see any negative sign here. Where is sine positive? I know according to my class diagram, it says all sexy teachers care. It goes like this. So where is sine positive? Sine is positive in the first quadrant and also in the second quadrant, and those are the only two quadrants where sine is positive. Now that I'm done with hint number 1, I go to hint number 2. I go and look for all the quadrants that are between 90 and 270. How do I identify those quadrants? I know that this is 0 here, this is 90, this is 180, this is 270, and this is 360. So which quadrants are between 90 and 270? Here is 90, here is 270. So the quadrants that are between 90 and 270 is quadrant number 2 and quadrant number 3. So in order for me to be able to draw my diagram, I go and take a look at where on this diagram do I have 2 ticks. I have 2 ticks in the second quadrant. I have 2 ticks in the second quadrant, and then that is where I am going to draw my diagram. So let's draw our diagram. So this is how I draw my diagram, and I complete my diagram. It's a 90 degree, it's a right angle triangle. I have beta right here, so sine is opposite over hypotenuse, so opposite is 2 the square root of 6. Hypotenuse is 5, meaning that there is something missing here, which is the value of x. And how do I get the value of x? I make use of the so-called Pythagoras theorem. So Pythagoras says that x squared plus y squared is equals to r squared. So this is Pythagoras theorem. So what is the value of r? The value of r is 5. The value of x, I don't know it as yet, but I'm going to figure it out. And then I plug that into the calculator. It gives me the answers. So 5 squared is 25. So I write it down here is 25. X squared remains x squared. And then this height here is 24. So I write it down that is 24. I take 24 to the other side. I get 1, meaning that 1 is equals to x squared. I solve for x. I get that x is equals to plus or minus 1. Now I need to make a conclusion. So how do I conclude? X can only be negative 1, because I know that the values of x that are on the left hand side of the y-axis here are negative. The values of x that are on the right hand side of the y-axis are positive. The values of y's that are on that are above the x-axis are positive, the values of y's that are below the x-axis are negative. Now that my diagram is complete, I can now answer the questions. The first question says, calculate the tangent of beta. Now, what is the tangent of beta? I am going to get my answer from the diagram. So I know that tangent is equals to opposite over adjacent. So opposite, the angle opposite beta is 2 the square root of 6. Adjacent is -1, meaning that my answer is -2 the square root of 6. Moving on to the second one, the question had wanted me to calculate the sine of 90 plus beta. Now to solve this equation, I first need to reduce. Now how do I reduce this? I'm sure by now you are familiar with this, that this is 0, 90, 180, 270, 360. So anything that is in this first quadrant here, you can say it is the angle itself. Maybe if you have theta is theta itself, or 90 minus theta, or 360 plus theta. Everything that is in here is 180 minus theta, or 90 plus theta. In here we have 180 plus theta, or 270 minus theta. In here we have 360 minus theta, or 270 plus theta. So we're going to take a look at 90 plus. So 90 plus belongs to the second quadrant. So now we take a look at what happens in the second quadrant. How is sine in there? So all sexy teachers. Okay, so we are going to take a look at how is sine in the second quadrant. So sine is positive in the second quadrant, so our answer is going to be sine of beta. So what is the sine of beta? Sine of beta is opposite over hypotenuse, so it's going to be 2 the square root of 6 over 5. Now moving on to another one. The question says, if sine of 28 degrees, so here's the question, says, if sine of 28 degrees is equals to m, determine the value of the following in terms of m and without the use of a calculator. So every time I come across a sign of a particular number is equals to a particular alphabet, I refer to this as an alphabet problem. So how do I deal with an alphabet problem? The first thing that I do, I divide that alphabet given to me by 1. So they had said to me that sine of 28 degrees is equals to m. I divide that m by 1. After dividing it by 1, I draw a diagram. I draw a diagram. So and then I put in all the angles in there. So I know that sum of angles in a triangle, they add up to 180 degrees, meaning that if this is 28, this one has to be nothing but 62 degrees. And then I label my triangle. Sine is opposite over hypotenuse, so opposite of 28 is m, hypotenuse is 1. And then I make use of the Pythagoras theorem to find the remaining side, which is x squared plus y squared is equals to r squared. It's called the Pythagoras theorem. Our r is 1, x I don't know about it as yet, y is m squared. Then I solve for m, so it's going to be 1 minus m squared is equals to x squared. So I take the square root here, take the square root here, which means that the value of my x is going to be equal to the square root of 1 minus m squared. I write it down here so that I can see it directly from my diagram. Now that I have a complete diagram, I can then attempt to answer the questions. So the first question is sine of -28 degrees. So So it's the sine of a negative angle. Sine of a negative angle, I take out the negative, it becomes negative sine of 28 degrees, and then I get the answer from my diagram. Minus, what is the sine of 28? It was given to me that sine of 28 is equals to m. So the answer is negative m. So now we move on to b. B is the cosine of 478. So what I often advise people to do whenever they come across an angle that is above 360 degrees, I advise them that they must subtract 360 from that 478 up until they get a number between 0 and 360. So let's see what happens when you subtract 360 to that. We get cosine of 118. Now 118, is it in this diagram? Of course not. So what is it that you need to do? I need to find a way of writing this in terms of a special angle and an angle that is already in the diagram. So the easiest way to go about it is to write it down as the cosine of 90 degrees plus 28. And then when you get here, you reduce this. So 90 plus, it is in the second quadrant. How is cos in the second quadrant? Is negative. So this is 90, it means that the cos will change to become sine. So this becomes sine of negative sine of 28, meaning that this is negative is right here. Sine of 28 is m. We're moving on to C. C, they said calculate the cosine of 28 degrees. So we check, do we have 28 degrees in the diagram? Yes, we have 28 degrees in the diagram. So what is the cosine of 28 degrees? It is adjacent, which is the square root of 1 minus m squared over 1. That is our answer. D, they want the tangent of 28 degrees. So the tangent of 28 degrees, you are also going to get it from our diagram. Tangent is opposite over adjacent, which is the square root of 1 minus m squared. That's how you go about it. Now I'll be ending the video with this proof question. So 9a, the question says prove the following identity. Now I must prove that the left hand side, which is this side right here, that it is equal to the right hand side. So how do I go about proving it? I pick one side. So from these two sides, I'm going to pick the left hand side. Why do I pick the left hand side? Because I see that left hand side has got two terms. So I believe that there is more that I can do to these two terms to get there, to get what is on the right. So what is on the left is 1 plus 1 over tangent squared of x. So how do I move on? How do I go about to solving this? I can write this as 1 over 1 plus 1 over tangent squared of x. And then from here, how do I take it further? So normally there is this simple thing, or this strategy that I like. It says a over b plus c over d will always be equals to, underline, you multiply the denominators, they give you bd, and then you sort of cross multiply the numerator and the denominator, it will be ad, you keep the middle sign, and then you cross multiply these ones, they give you cb. So I'm going to apply this method into simplifying this problem right here. So what I'm going to do, you underline, firstly you multiply the denominators, you get tangent squared of x. From here I cross multiply, multiply this one by this one, it gives me tangent squared of x. I keep the middle sign, I multiply this one by this one, it gives me 1. But am I done? Of course not. I am not done. So what I have there on the left is nowhere close to what I have on the right. What I have on the right has sine, is written in terms of sine only, meaning that I have to find a way of changing what I have here and write it in terms of sine. So how do I do that? So I know that the tangent squared can be written as sine squared of x over cosine squared of x plus 1. The tangent squared of x can be written as sine squared of x over the cosine squared of x. And then when I continue with this equation right here, to make it simple, I can write it down as sine squared of x over cosine squared of x plus 1. And this divide right here, I write it here as divided by sine squared of x over cosine squared of x. But now I need to deal with this. So how do I deal with this? Remember the strategy that I've just given you above here. So I can write it down as sine squared of x over cosine squared of x plus 1 over 1. And then the division, I can change the division into multiplication. So what happens when I change division into multiplication? What was on top comes underneath, and what was underneath comes on top. So meaning that the cosine squared will come on top and the sine squared will go underneath. And then I further simplify this equation of mine. One denominator, multiply the denominators, they give me cosine squared of x. Cross multiply this one times this one, sine squared of x. I keep the middle sign, this one times this one is 1, multiply the cosine squared of x all over sine squared of x. So now what happens? Cosine squared of x cancel the cosine squared of x, and what I have here is the sine squared of x plus 1 all over the sine squared of x. So now my equation is almost similar to what I needed to prove. The only thing that needs to disappear right there is the sine squared of x.